Good day to our lecturer, Madam Indian. Today, we Group 7 will be presenting our cloud migration project, which details the end-to-end strategic transition of a traditional legacy on-premises car rental system over to an enterprise-grade cloud ecosystem on Amazon Web Services. As you can see highlighted in the sidebar navigation of our presentation poster, our project group is made up with 5 members working collaboratively. Myself, Ishwar, alongside CA, Arivan, Divya, and Hamza. For this academic study under the course TCC 4223 Introduction to Cloud Computing, our team set up to analyze how small to medium enterprises or SMEs in the global transport sector can successfully break away from old physical computing limitation to adopt a modern, highly available business model. Let us focus specifically on the top section of our poster highlighted right there, the legacy problem on premises infrastructure. In today's digital economy, consumer behaviors and expectations shifted dramatically. Customers no longer want to wait. They expect instant 24-hour access to check vehicle inventory, see live rental pricing, and make immediate bookings from the comfort of their home using their mobile devices or web browsers. However, as stated in our core challenge text on the poster, SME car rental companies traditionally rely on localized on-site desktop architectures. This means their entire system, including the core renting project database, fleet schedules, profile management, and payment processing engine, is physically locked inside local tower servers situated right at the corporate headquarters building. Our research proved that these legacy implementations create severe operational constraint, high maintenance burden, and critical single points of failure that actively block modern business growth. When your software operates strictly within a localized group, you cannot scale up for peak or irregular seasons. Your data is vulnerable to physical disasters and you face high operational expenses just trying to keep the hardware running. Simply put, running a real-time transport business of a physical back office server is an unsustainable risk in a digital first market. Now, to break down exactly what this infrastructure limitations translate into day-to-day business problem, I will pass to who will take you through our specific key bottleneck. Thank you.
Now let's look at the main problems or key bottlenecks in the current system. The first problem is high initial cost. Companies need to spend a lot of money at the beginnings to buy servers, network devices, and set up a server room. This is very expensive, especially for small businesses. They also need to pay more later for maintenance and upgrades. The second problem is system downtime risk. Since everything is stored in one place, if something goes wrong means like a power cut or server failure, the whole system stop working. This means no booking, no payments, and no businesses operations. This can cause uh, loss of money and unhappy customers. The third problem is no remote access. People can only use the system in the office. Customers cannot check uh, car or make bookings for home. Also, staff and managers cannot access the system when they are not in the office. This is not suitable for today's digital world. So, in short, the current system is expensive, not reliable, and not flexible. That's why we need a better solution like cloud computing. Thank you.
Good morning everyone. I'm CD. Now I'll explain the proposed AWS cloud solution for our car rental system. The main idea of our proposed solution is to migrate the existing on-premises car rental system to the AWS cloud. Instead of depending on physical servers located in the office, the entire system is hosted on AWS. This provides better scalability, higher availability, improved security, and easier maintenance. Customer can access the car rental system anytime and anywhere through the internet, while administrators can manage the system more efficiently. Okay, now I'll explain the first cloud product, which is Amazon EC2. Amazon EC2 or Elastic Compute Cloud act as the main application server for our car rental system. It hosts the website and processes all customer administrator requests. For example, when customers search for available vehicles, make bookings or complete online payments, these requests are handled by Amazon EC2. Then, one important advantage of EC2 is its ability to automatically scale resources during busy periods, such as public holiday or festive season when more customers book car rental. This ensures that the system remains fast and stable even when the number of users increases. Then next is Amazon RDS, which stands for Amazon Relational Database Service. Amazon RDS is responsible for storing all the important data in our car rental system. This includes customer information, vehicle details, booking records, payment information, and rental history. Instead of managing physical database server, Amazon RDS provides a fully managed database service. It performs automatically backups, simplifies database maintenance, and support database scaling whenever the system grows. This improves the data reliability and reduces the workload for the company's IT staff. By combining Amazon EC2 and Amazon RDS, our cloud solution becomes more reliable, scalable, and cost-effective compared to the traditional on-premise system. The company no longer needs to invest heavily in physical servers while customers enjoying a faster and more accessible online car rental service. Thank you. That's all for me.
Hello, my name is Divya and I will be presenting the Amazon S3 and Amazon CloudWatch part. Moving further into our proposed AWS architecture, let's look at how we handle data storage. In our legacy on-premises setup, storing large files like vehicle images and customer driver's license locally takes up massive amounts of expensive disk space on our primary servers. To solve this, we introduce Amazon S3 or Simple Storage Service. By utilizing S3, we can offload these heavy static assets completely away from our main compute instances and into highly durable secure object storage buckets. This not only frees up critical server storage but also ensures the essential customer documentation is safely stored with world-class durability, ready to be retrieved whenever a booking is processed. But building a modern cloud environment is only half the battle. We also need to know exactly how it's performing at any given second. That brings us to Amazon CloudWatch. Under the old legacy model, if a local server room crashed, we usually only found out after the system went down and operations ground to the halt. CloudWatch completely changes that paradigm by delivering 24/7 continuous system performance observability. It tracks our server health, monitors traffic spikes, and features automated alerting mechanisms. This means if our CPU usage spikes or database storage runs tight during a holiday rush, CloudWatch alerts our team before failure occurs. allowing us to proactively resolve metrics and guarantee zero operational downtime for the car rental branches. That's all for my part. Thank you.
Hello, my name is Amza Shami, and today I present the comparison matrix of our cloud migration legacy to AWS poster. This comparison matrix summarizes the main differences between our legacy on-premise car rental system and the proposed AWS cloud environment. It highlights why migrating to the cloud is a better long-term solution than staying in the old system. For our first comparison, we look at the financial strategy. The legacy system follows a capital expense or CapEx model where the company needs to spend a large amount of money upfront to purchase servers, networking equipments, and backup hardware. In contrast, the AWS cloud environment uses an operational expense or OpEx model where the company only pays for the cloud resources it actually uses. This reduces initial costs and provides greater financial flexibility. Next is the system scalability. With an on-premise system, expanding capacity requires purchasing and installing new hardware, which is both time-consuming and expensive for the company. In the cloud environment, resources can scale automatically based on demand. For example, during holiday seasons, when more customers are booking cars, AWS can automatically allocate more computing resources without manual intervention. The third comparison is the system availability. The legacy system is vulnerable because everything depends on local hardware. If there is a power failure or server breakdown, the entire system could become unavailable. The AWS improves this through multi-availability zone deployment, where applications are distributed across multiple data centers. This provides a high availability with a 99.99% uptime service level agreement and reduces the risk of service interruption. The fourth and final comparison is the data protection. In a traditional system, backups are performed manually and stored locally. This makes them vulnerable to hardware failures or natural disasters such as floodings. AWS provides automated cloud backups through Amazon RDS and highly durable storage using Amazon S3. This ensures that important business data remains protected and recoverable in case of a disaster. That's all from my presentation. Thank you.